Okay, we're here with Dr. Kirk Bertsche, and maybe you can just tell us your background, your degrees.
Yeah, okay. So my PhD is from Berkeley in physics, and my project was to design and build and make work a new small particle accelerator to do radiocarbon dating. And then I went and my career has basically been accelerator design, particle accelerators and also electron microscopes and other similar charged particle optics sort of devices. But after my PhD, I worked as a postdoc for a few years at Lawrence Livermore Lab, where we had a big carbon dating facility and did carbon dating. And so I'm familiar with some of those techniques and working on the preparation of samples. And I prepared a number of samples myself and then dated them in the machine. But then after that, it's been more working on the machines and the hardware and the particle accelerators.
Maybe you can make some comments on the RATE project.
Yeah, there's a paper I wrote up on it, analyzing their work a few years ago, and we can probably get a link to it on your website or a copy. And yeah, the RATE project was, it stood for Radioisotopes and the Age of the Earth, and this was a project by the Institute for Creation Research, ICR, and they were trying to look at the various radioactive dating schemes. They realized this was one of the evidences for an old Earth, and they wanted to try to reinterpret it in a young Earth perspective and make it fit with what they thought they saw the Bible presenting as a 6,000 to 10,000 year old Earth. So as I understand it, that was the motivation for their project. And one of the pieces of the project was to look at radiocarbon. So they did a bunch of looking at old data from the literature and also some of their own new data, new samples that they had done of various things.
Maybe you could tell about the diamond that they did testing on.
Yeah, they did some tests on diamond, and they concluded that there was some radiocarbon in the diamond where there shouldn't be, because the diamonds are so old they shouldn't have any measurable radiocarbon. And it's interesting to look at that data. What they did, the work that is reported in the RATE report, they took diamond and had it crushed up, and then had it, the lab that they used converted the diamond to methane through a combustion process, and then it reduced it to graphite to measure it in their accelerator. And all of this conversion generally adds a little bit of modern radiocarbon. It's not completely clean. It adds a little bit of background. And then what the folks reported in the RATE report was not the number minus the background. Well, hang on, I'm not quite sure of that. They reported some numbers, though, but I suspect they had a higher background because of the difficulty of converting this diamond to methane. It's very hard to, it's a very hard material. It's hard to combust it. And I had done a project at Livermore where I worked on some iron artifacts and tried to pull the carbon out of the iron. And that was also difficult. It required a much higher temperature combustion than normal. It required special tubes to do the combustion in. And so it just makes the process more complicated, and it gives it more chance to get modern carbon incorporated in the sample, which makes it look like there was carbon in the sample, where all you've done is just add modern carbon from your chemical processing.
What about coal? In the testing of coal, there seems to be still some measurement you can get.
Yeah, and coal, the same thing. The RATE project looked at some coal samples that had been stored in a DOE repository in Pennsylvania, I believe, and they measured some samples of coal, and they found radiocarbon in what they measured. Now the coal seems to be a little bit different. in terms of the source of the radiocarbon. There, if you look at the rate data, and we'll try to get you a link to put on your website, if you look at the rate data and look at the coal, you see that the different coal samples had a wide range of radiocarbon, a factor of about 5 from the lowest to the highest amount of radiocarbon. And if the rate theory is correct, their theory is that this is radiocarbon that's left over from the creation. They have a couple problems with that theory. First problem is that would make it 40 to 45,000 years old, and they want a 6 to 10,000 year old creation. So they have to then hypothesize that there was some rapid, accelerated radioactive decay early in the universe. But even so, their theory would say that all of this coal should have about the same amount of radiocarbon, because it's all the same age, and it all underwent the same kind of accelerated decay. But what we see in the data is a wide range. It's a random distribution of radiocarbon in these coal samples. And that's much more consistent with the theory that this is contamination of the coal. And we know quite a number of methods where coal can be contaminated. There's a number of things in the literature about coal contamination. Coal is often soft, and it often has groundwater flowing through it. It sometimes has biological activity in it. As soon as you dig the coal out, it tends to absorb CO2 from the air, and even while it's in the ground, if it's near uranium or thorium deposits, those can convert nitrogen into radiocarbon in the coal and make it look young, or younger than it really is. And so there's quite a number of things, and many of these things have been tested and measured in the literature. You can find estimates. So I don't know exactly how their coal samples were contaminated, but the widespread in their data seems to point toward contamination of the coal, not toward this as being the real original radiocarbon that was in the coal.
Okay. Any other comments on the rate?
Well, they did it was brave of them to attack the radiocarbon and try to re-explain it, and I think they did a very good job of trying, but I think in the final analysis, their analysis just doesn't work, and the coal is better explained by contamination, and their own data points more toward contamination than anything else. The diamond is better explained by laboratory processing. I should add too that they did some, subsequent to their work, I think unknown by Taylor and Southen. Taylor and Southen, who were two of my mentors, by the way, they did some work on diamond themselves, where they took a pure, an unprocessed diamond. They didn't crush it up and convert it to methane or CO2. They just took diamond and put it right into the accelerator and tried to get a date off of that. They weren't really trying to date it, though. They were trying to see how much radiocarbon they would get off of it. And this was a measurement to work on a theory of how their ion sources in these accelerators can cross-contaminate one sample to the next. And their theory was that diamond, since it doesn't tend to, what do they call it, hygrophilic, water avoids it. Water doesn't tend to stick to diamond. And because of that, they thought diamond would tend to be cleaner and pick up less contamination from the other samples in the ion source. So they did this experiment, and sure enough, they found out that their diamond had a much lower amount of radiocarbon than the other blanks that they were using. So they verified that their data verifies that the carbon they were seeing was coming from the ion source itself, not from the diamond. And there's a few pointers in the data that I point out in my paper that indicate that. They were just finding a cross-contamination from the ion source because of previous samples splattering carbon on the inside of the ion source and that coming off and sticking to the new sample. So, and then subsequent to that work, Rate did some more samples in the same way, where they did unprocessed diamond, and they got pretty much the same results as Taylor and Southen. As far as I know, that new analysis by Rate or new data by Rate has not been published. And I'd like to see what they say about that, because their processed diamond gave a value of radiocarbon, which I believe is processing contamination. Their unprocessed diamond gave a much lower value. So obviously the numbers they got from the processed diamond are not intrinsic either, because that's not what they saw on the unprocessed diamond. So there are a lot of puzzles in their own data that they haven't explained well.
Okay, well, thank you very much. I appreciate your comments.
Okay.